Welcome to the Explainer. So, today we are unraveling one of the absolute greatest recent mysteries in space exploration. For years, literally years, the TRAPPIST-1 star system was the holy grail of exoplanet research. It was hyped up all across the globe as our very best chance at finding another Earth. But, as we're about to see, the universe has a funny way of shattering our expectations and replacing them with realities that are even more mind-blowing. I want you to really think about this for a second. Is TRAPPIST-1 our next home, or just a cosmic mirage? Because honestly, for a long time, the scientific community genuinely thought we had hit the jackpot. But today, we're doing a deep dive into the massive gap between what we expected to find out there in the dark and what the absolute latest, most powerful data is actually telling us. Part 1. The Earth 2.0 illusion. Okay, so the whole hype train basically hinged on this idea of the habitable zone. You know, that theoretical sweet spot for liquid water can exist. That's the baseline for life as we know it. And TRAPPIST-1's location right in this prime orbital real estate was the main reason it caused such a massive stir in the astronomical community. Let's dive into this, because finding just one rocky planet is a huge deal, right? But TRAPPIST-1, it gave us seven. 7 rocky planets all packed into a single system, and 3 of them were sitting squarely inside that habitable zone. Plus, they were incredibly similar in size and mass to our own Earth. Out of all of them, TRAPPIST-1d was viewed as the absolute prime candidate. On paper, it looked like the perfect place to search for water and just maybe life. It had a flawless resume for an exoplanet. Part 2. JWST clears the fog. To really grasp why the James Webb Space Telescope, JWST, is such a game changer here, I absolutely love this quote from astrophysicist David Singh. He says, "We've known for quite a while that clouds are pervasive on hot Jupiter planets, which is annoying because it's like trying to look at the planet through a foggy window." And he's totally right. With older telescopes like Hubble, we were basically just getting this blurry, squished together, averaged out view of these alien atmospheres. But JWST, it completely flips the script. Its super-sensitive infrared sensors essentially act like a giant cosmic defogger. For the literal first time in human history, we have the tech to pierce right through that atmospheric haze and map out the true, specific chemical makeup of alien worlds. So, naturally, scientists turned this ultimate tool directly toward our perfect candidate, TRAPPIST-1. Part 3. The TRAPPIST-1 reality. Now, what's really interesting here is the stark contrast. The expectation was that Planet D was this perfect, Earth-sized rocky world ready for life. The reality? Well, JWST data firmly reveals that TRAPPIST-1d does not have an Earth-like atmosphere. At all. And unfortunately, neither do its sister planets, B and C. The illusion was completely shattered. Despite its perfect location in the habitable zone, Planet D is most likely just a totally barren rock. Part 4. How atmospheres are lost. So how exactly does a planet sitting in the literal perfect location end up totally dead? Well, we actually don't need to travel light years away to figure that out. We just need to look at our own planetary neighbor. Mars is the absolute perfect local example of a world that lost its protective shell. And you've got to understand, this is a problem that is literally billions of years in the making. And it all comes down to this number right here, 100 grams. According to incredible data from NASA's MAVEN orbiter, that is the exact amount of atmosphere that Mars loses to the solar wind every single second. Tick, 100 grams. Tick, another 100 grams. Over billions of years, that slow bleed completely alters the fate of a planet. Let's move on and see how this builds, step by step, into a total planetary catastrophe. Step 1. The planet's internal core cools down, which essentially unplugs its protective magnetic field. Step 2. Without that magnetic shield, high-velocity charged particles from the star, the solar wind, relentlessly bombard the unprotected planet. Step 3. Gas molecules are systematically stripped away into the vacuum of space. And get this, during a solar storm, that escape rate multiplies by a factor of 10. Without a magnetic field, your atmosphere is just systematically sandblasted away. Part 5. Impossible planetary atmospheres. Now, we've got to pivot here, because this is where the universe gets wonderfully weird. Think about it. If a prime candidate like TRAPPIST-1d somehow lost its atmosphere, what about planets that absolutely shouldn't have one but actually do? Turns out, the cosmos refuses to play by our rules. As JWST peers deeper, it's uncovering a sheer unpredictability out there that is just thrilling. We are finding worlds that completely defy all our established models of atmospheric physics. I mean, just take a look at the wild diversity on display here. This brilliantly illustrates what Webb is finding. We've got TOI 561b, nicknamed the wet lava ball, which is scorching hot, but somehow kept its atmosphere. There's WASP 94ab, where rock clouds literally vanish every evening. And then there's PSR J2322-2650b, a lemon-shaped world where it literally rains diamonds. Let's break these incredible anomalies down. Okay, first up, TOI 561b. They call this one the wet lava ball. It's an ultra-hot super-Earth, meaning it is so close to its star that its surface temperature is a blistering 3,200 degrees Fahrenheit. The entire surface is a global magma ocean. Now, logic says a small, incredibly hot planet like this should have its atmosphere instantly boiled and stripped bare. Yet, Webb data shows it retains a thick atmosphere that actually helps cool its day side. The working theory? That global magma ocean is constantly burping out gases from the planet's interior, replenishing the atmosphere in a relentless cycle. It is literally a wet lava ball. Next, we have WASP 94ab, a hot Jupiter sitting about 700 light-years away. And JWST managed to do something unprecedented here. It mapped the planet's daily weather cycle. In the morning, the skies are densely packed with magnesium silicate clouds. Yeah, you heard that right, clouds made of actual rock minerals. But by the evening, the skies are completely clear. As the atmosphere rotates into the planet's intense 1,000+ degree heat, these rock clouds completely vaporize. I mean, it's the most extreme meteorology you can possibly imagine. And then, oh man, there's PSR J2322-2650b. When astronomers first got a look at this data, the reaction was just pure, genuine shock. This is a Jupiter-mass planet orbiting a dead, rapidly spinning pulsar star whose immense gravity stretches the whole planet into the shape of a lemon. But it gets weirder. Its atmosphere has zero carbon dioxide or methane, none. It is made of pure molecular carbon, C3 and C2 molecules. Soot clouds drift through this bizarre atmosphere, and deep inside, they condense and rain down as actual diamonds. It breaks every single formation model we have. It's a completely new type of world. Part 6. The Endless Cosmic Variety. Discoveries like TOI 5205b prove that the rules are just constantly being rewritten. This is a Jupiter-sized gas giant orbiting an incredibly tiny star, a star only 40% the mass of our sun. According to the old models, a giant planet shouldn't even be able to form around a star that small. Plus, its interior is 10 times more metal-rich than its outer atmosphere, meaning the two don't even mix. These planets are showing us that our own solar system is just one tiny, highly specific example of how things can happen. Which really brings us back to why all of this actually matters for you and me. Look, TRAPPIST-1d might not be the Earth 2.0 we were all dreaming of, but a dead TRAPPIST-1 isn't a failure. Not at all. It's a vital stepping stone. It forces us to ditch our assumptions and begin to understand the true, staggering complexity of the cosmos. In a galaxy bursting with hundreds of billions of planets, we are literally just scratching the surface. So I'm going to leave you with this one final provocative thought to chew on. If the actual rules of planet formation are being completely rewritten on a daily basis by telescopes like James Webb, what impossible world will we find tomorrow? Thank you so much for joining me on this explainer. Keep your curiosity alive, and as always, keep looking up.